Hi, this is Mrs. Apone, and today we're going to take a look at scientific notation. And we're going to ask, what is it? Why do we need it? And then a little bit after that, we'll look at how we do it. And that'll probably be the next video. This number right here is actually an example of a number in scientific notation. And this is a very important number in science, especially so in chemistry. And you'll learn about that a little bit later on. Avogadro's number. I like to start scientific notation with a few questions, and I encourage you to pause the video and write down some guesses. You can't get it wrong, just take a guess. If you were to start right now without stopping, how long do you think it would take you to count from 1 to 1 million, 1, 2, 3, 4, 5, and so on? How many atoms do you think there are in one single cup of water? And if we had a scale big enough, what is the mass of the Earth in grams? And what is the mass of a single electron? If we don't know what an electron is, we're all made up of these tiny little things called atoms, and atoms are made up of protons, neutrons, and electrons. So it's something smaller than an atom, something inside of an atom. So what is the mass of a single electron? So think about these 4 questions, come up with a guess, and then move forward to the next slide. It would actually take you 23 days if you were to start counting right now from 1 to 1 million. And you might say, that's no way, that's crazy. But it is true. I have students every year. I usually give them about a week or two, and I tell them, if you can draw a million tiny little stars in your notebook, I'll give you a 99 for the year. And you won't have to do anything in class. And a few of them start. Some get to 7,000, some get to the 20,000s. They all give up. A million is a very large number. It's actually much larger than we think it is, but it would take you about 23 days to get to a million. And the rule of thumb here is it takes about 2 seconds to say a number when you start getting to the larger numbers. So 2 million seconds converted into days is about 23 days. So if you think about it, 444,445, 444,446, and so on and so on. Those numbers are big. A lot of syllables take about 2 seconds to rule. And we probably have already read this book in class, or we will actually read this book in class, and we'll figure out how long it takes to count to a billion and also a trillion. A wonderful, wonderful book. So, in a cup of water, there are 24 something with a lot of zeros, atoms of water in it. That's a pretty big number. There are more atoms in a cup of water than there are cups of water in all the oceans combined. And I wanted to say just ocean because there's only really one ocean, but we name it parts, different areas of it, one part, but there's not different oceans on the Earth. So in all the water, even all the water in all the oceans on the Earth, there's this many atoms. And students often ask me what this number is, what numbers are after a trillion. This is hundreds, thousands, millions, billions, trillions, quadrillions, quintillions, septillions, sextillions. I believe after that comes octillions, novillions, and decillions. I don't even know how to pronounce it. I know how to spell it, but that's the general number sequence. So I believe this was 24 sextillion, this number. That's the number of atoms in one glass of water. Now imagine how many glasses of water there are in the ocean to figure out how many atoms of water there are. Say, not even on the Earth, because there's water in the air, there's water in lakes, there's water on the ground, there's water in our bodies. So there's a lot of atoms of water. Atoms are very, 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 very tiny. And that might give you some idea why we need scientific notation. The mass of the Earth, if we had a scale big enough, well, this would be the mass of the Earth. And if you wanted to, you could figure out what that number is using the last slide. It'd just be a very, very big number. And when I write these on the board, it's like, is he still writing zeros? Yes, he is. This is the mass of the Earth. You'll learn in physics how to actually calculate this, and the mass of the moon using a little bit of orbital dynamics, probably Newton's law of universal gravitation. So again, a very big number, and this one is probably has the most zeros out of all of them. This is the rest mass of a single electron. 9.11 times 10 to the negative 31st kilograms. A very, 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 very small number. Lots of decimals, a fraction of a fraction of a fraction, and so on. So it goes without saying that in science, there are a ton of really, 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 really small objects and a ton of really, 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 really big objects. And I have to ask you, what number would you rather put in your calculator? What number would you rather write out if you had to? This number or this shorthand abbreviation for that number? This exponent here is kind of telling me how many zeros you need to put in. It's a shorthand way scientists like to use it because we're lazy. We don't want to write out this long number. I think you would rather use these numbers as well. And this should be 10. And sometimes you'll see this caret that indicates to the 27th power. So 9.11 times 10 to the negative 31st. And we'll talk about what that means later. But whenever you have a negative sign, it means it's a really small number. Whenever this exponent here is positive, it means it's a really big number. So we can already see that scientific notation is going to be more convenient and more easy whenever we're dealing with very large or very small numbers. And if you're ever doing calculations with these numbers, not only do you have to write these numbers out, you have to actually multiply and divide them together in a calculator. So this is a really simple equation in physics. This is Newton's law of universal gravitation. F equals G m1 m2 over r squared. Very simple law. You learn about this in physical science and physics. So if we wanted to calculate the force of gravity between the sun and the earth, these are the actual numbers we would put into our calculator. This is your G value. This is going to be the mass of the sun. And I didn't put units in just because it's overkill at this point. This is the mass of the earth, kilograms. And r squared is the distance between the earth and sun squared. You have to put all these numbers in your calculator. Can you imagine trying to put this into your iPhone? It's never going to happen. Just insane. But if you were to put these numbers in scientific notation, it becomes much, much more convenient to put in your phone. And there's actually a trick to scientific notation. You don't even have to put these in your phone. When you're multiplying numbers in scientific notation, you can actually just multiply these three numbers together, and then you can add up all of these exponents. And we're going to talk about that in a future screencast. It's much, much easier to do really large and really small numbers in scientific notation. Divide them, add them, multiply them. There's tricks that, you can do this calculation before you even got your calculator out. This number is really close to 6. This number is really close to 2. 2 times 6 is 12. Times 10 to the, and you add these two exponents, 30 to the 54th. And that's what, if you put these two numbers in your calculator, that's about what you would get. 12 times 10 to the 54th. You can do that in like 2 seconds. Obviously, I estimated a little bit there. If you were trying to land the rocket on the moon, you'd want to put in the exact numbers. But generally, if you have simpler numbers, you can do scientific notation in your head before you can even pull your phone out or your calculator out. Scientific notation makes it much easier. So what is scientific notation? It's an abbreviation for very large and very small numbers in science. It's a way to write numbers much more easily, and a way to perform arithmetic operations on those numbers in a much simpler fashion. So that's what it is. Why do we need it? Well, because there are a ton of very small and very large numbers in science. There's a whole micro world, things much, much smaller than the eye can see, and there's a macro world, things much bigger than the Earth, much bigger than the sun, much bigger than our solar system. So there's a lot going on in the world around us. Very small, very big things. And of course you have an assignment now. And there's a wonderful app showing you the entire scale of the universe. And if you click this picture right here, it should take you to the app. The link is actually popping up. If for whatever reason that's down, you can find another version there. I kind of snagged a copy of the Flash just in case it goes down. But use this website. It's a wonderful, wonderful video. Scroll through it. You'll see objects going from the hypothetical smallest known objects to the largest objects in the universe. And I want you to just identify 5 objects smaller than the eye can see, so you'll have to find that on there. If you click on any of the objects in the video, a pop-up will appear, and it'll tell you the size of it in scientific and standard notation, and it'll tell you description of it. So describe what the object is, these 5 objects. Do the same thing for the sun, except find 5 objects bigger than the sun. We're going to go for small objects up here, big ones here. Do the same exact thing. After looking at the app, is the sun a large object on astronomical scales? You tell me that. Once you get to the sun and you scroll past it and see what's bigger than it or smaller than it, tell me if the sun is big in terms of astronomy. And finally, a simple question. I kind of went over this in the last slide. What is scientific notation? Why do we use it? Hopefully you're going to tell me it's some sort of abbreviation for big and small numbers, and it makes writing and using them much simpler. This is Mr. Sapone. Hopefully you have an understanding of what scientific notation is and why we need it. I'm out.